Thank you for joining us for the advanced breakout on connectors and automated rule processing. Remember, keep that chat open, write in those comments and questions. It sounds like we're going to probably save them for the end and do them all at once. So just know I'll be seeing them and keeping track of them. So now it is my pleasure to introduce Steve Boisvert, Knowledge Aware Consultant at Oros Knowledge Systems. Take it away, Steve.
Yeah, thank you, Amy. Hey, it's great to be here with everybody. I'm glad everyone came back. Unfortunately, we're virtual again, but that's all right. We have a lot of good content to go through. Let me get my screen going here. All right, hopefully you guys can see my screen now. The plan for today is I want to take you through what it means to connect Oros, or I guess knowledge, into other applications. So what it means to deliver knowledge as a service. This is one of my favorite topics because, oftentimes you kind of get mixed up into this kind of, well, how does that really apply to me? I don't really see how this whole knowledge aware thing will work. And, throughout doing these presentations over time, I just feel like people can connect with this topic very easily. So to kind of get into it, so we have enough time to get to the demonstrations at the end. Like I said, the plan is to focus on connectors and automated rule processing and how we can advance an organization's ability to become more knowledge aware. I'm going to walk through a few slides to establish a baseline of knowledge, and then we're going to review some live demonstrations to see how things work. Some key takeaways from today. What is knowledge as a service? Right, we want to know how we can provide knowledge as a service into other applications. How does Oros IQ provision that knowledge into these other applications? What's the mechanism that's behind that? What is automated rule processing and what does it look like? And then how do we keep data synchronized between these two applications? So with that, let's kind of get into it. If you guys were in the big picture, expanding picture presentation with Jeff, you've seen this slide, transformation of knowledge, right? In his presentation, he talked about how knowledge aware technique is very similar to navigation, delivering the right information at the right time. And I don't really want to get into all that, but what I do want to kind of focus on is how these connectors to applications you utilize every day to make your products are really a key mechanism to help us detect context. What are those things you're working on? What's the material of this object? What kind of product platform are you working on? Those kind of things to detect that context of what are you trying to do to help us deliver the right knowledge just in time, and then how we can evaluate that knowledge and feed that back into the system to make knowledge better for the next person. So just as GPS uses that context to give you the map tiles, we can detect context from these other applications, deliver just the right knowledge to you. So before we go too far, just kind of a baseline. Jeff also touched on this a little bit, but for those of you that may not have attended his presentation, the fundamental technologies that we need to have in place to make this knowledge aware approach work are the knowledge packet, the assessment control, and the rule processing engine. And quickly, I'm just going to briefly touch on these. The knowledge packet, it's a granular unit of retained know-how, or structured unit of retained know-how. Jeff mentioned there's three properties: the granular, actionable, and modular. And one of the key things I want to touch on, in a key area of a knowledge packet that makes this whole application connection process work, are these value tables, right? These little mini knowledge models that we can embed within a knowledge packet that allows an author to kind of be very specific with the intent of a knowledge packet. It allows us to really break down what the knowledge packet is used for, and we can identify things like parameters. So if we look at this particular knowledge or value table here, the knowledge packet, it's talking about locator pin engagement. We've broken that down into this little logical model that's saying the minimum locator pin engagement is 45% of the part thickness, and the maximum 60% of the part thickness. And there's two parameters actually in this value table. Part thickness is a parameter that, that's something that we could detect from another application, like a CAD application. And then the output would be this locator pin engagement parameter, and that's what we're going to rule process against. So kind of to go back, this is a key part of making this process work. So in order to grab the right information, we need a toolkit that goes out and not only detects context, but then also goes into the database, gets the right information, and provisions that to the key individuals when they need it. And Jeff mentioned this is we call it an assessment control. It's a thing where does that heavy lifting, goes out and finds the right knowledge. And then as that knowledge is evaluated or used in context of a process, we're tracking that information to see how well a product is or process is performing. And then we're also utilizing that knowledge to feed back into the system to make knowledge better over time. So this is one of the views that we have for an assessment control. Every line here is a knowledge packet, and we can provision that into the flow of work. He also mentioned there's another view, and this view is really important to us, being that the demonstration I'm going to perform is connecting this knowledge to CAD. So extracting kind of all that textual information out of a knowledge pack, and we boil it down to just those value tables, and we start looking at those parameters. We can view the parameter view of a set of knowledge packets within an assessment control and see how they're performing. We can get right down to that parameter, see its value, see if it's performing correctly or as anticipated or not. And we can kind of see that with the colors here. And I'm going to show how this all happens within a CAD application. And then lastly, to make this all work, we need a rule processing engine. We need that set of services that understands these parameters, and we understands the rule, the context of the rule, and then given the inputs can process that knowledge and deliver back a quantitative state, whether things are good or bad or as anticipated or not. And to kind of show how this works, so how all of these things work with an external application, whether it be a CAD application or a simulation tool set, or even just a PLM system for that matter. There's a particular way in which information is transferred between the primary application where individuals do their daily work and the knowledge repository. So kind of to illustrate that, we have our external applications on the left. And as I mentioned, there's context in those applications. There's part information. There's who's operating that particular application. Maybe it's something like material or product structure. Whatever that happens to be, we can utilize that information, send that into OROS, collect the right knowledge. Once we've collected that right knowledge, we can send the key parameters from that collection of knowledge packets back into that CAD application, where once it's in that application, whether it's CAD or some simulation tool or PLM, we connect those key parameters to objects within the model. Maybe it's a design constraint or a feature or part property information or a measurement. Once we've connected those parameters, we can publish those values back into the rule engine, who can interpret those values and then respond with whether or not that was an expected outcome, whether things are good, bad, red, yellow, green, and display that information not only in the tool set, but also store that information in the knowledge repository where we can run all sorts of reports. And we can gain all sorts of insight of how a particular project is performing. So that's kind of the overview of how this is all going to work. And I'll show all this and we'll go through it all again once I'm in the CAD application. So one of the things I want to show real quick is a connector, because we get asked all the time, do you have a connector to this CAD application or that CAD application, or you're showing me this demonstration inside of NX, but can you show me this demonstration inside of Creo or CATIA or SolidWorks? And how does it change? Well, one thing I want to mention is the connector for our CAD applications is the same no matter which CAD system you have, whether you're in NX or CATIA or SolidWorks or AutoCAD or Ship Constructor or Creo. the view is going to be the exact same. The experience within the tool set is different because they're inherently different. The parameters inside of NX are called expressions, and they have a particular process you have to follow. Inside of CATIA, they're relations and parameters. And inside of SolidWorks, I think it's a global variable and part property. So there's differences inside the tool set for sure, but the connection to the application is going to be the exact same. So I kind of want to go through this because this is something that just kind of developed within the last year or so. And I want to make you aware of how this works. So it has 3 panels. We have a settings panel, which is the first panel. And this is going to show us, what model are we connected to? What OROS instance are we connected to? Where are we getting the knowledge? And then where's that knowledge source coming from? Is it from a knowledge packet set or from an assessment control? And there's others besides that we can do, but for today's demonstration, these are the 2 primary ones we're going to use, a set or an assessment control. The middle panel is going to identify, is there any knowledge that's not being consumed by the model? So this is where we're going to look to the knowledge repository, look at those knowledge packets, look at the parameters, and see if those parameters exist in the model or assembly or whatever it may be. And if they do, then the panel will show up empty, like you can see it here. If they don't, you'll see that the unmatched parameters will start to count how many parameters are not in the model. And that's an indication that there's new knowledge that can be consumed into the modeling application. And then lastly, we have the third section, which is the rule processing engine, or the responses, where we're going to see our qualitative rule output states, where rules are going to be evaluated. And once it's connected and working, you're going to see something similar to this, right? We see the parameters that are not connected in the middle. We see the red, yellows, and greens in the bottom. And that's going to show in the model. It's also going to be stored inside of the knowledge repository. So with that little overview, let's dive into the application. We're going to use NX. I always use NX for this demo, and I always say that the reason I use NX is because that's what I have on this laptop. And live demos, as Jeff mentioned, are riddled with all kinds of pitfalls, and I'm trying to avoid that by making sure I have the ability to connect and modify as needed with what I have on this machine. So let's get out of here, and we're going to open up our model. So you can see I have my little garage door opener model here. Quite the assembly. And what I want to do today is just go through kind of a basic example. And it's actually a real life example, one that many of our customers perform on a daily basis. And it's going to be a part-to-part assembly verification, and maybe even part to tool verification. So here's our model. We have a few parts, right? We have some different components. We can see a bracket, lens, motor, panel, real basic model with some fasteners and such. And I want to show you the knowledge that we're going to connect to. So let's go into OROS IQ, and we're going to look at my garage door opener community that houses all of the information we're going to use. And inside here, I have a set of knowledge packets that have been built that just looked at part-to-part clearances. So this one is a motor assembly clearance to the PC board, and you can see here there's a value table. 5 millimeters is the minimum. And to see how that works, once I connect this into the CAD system, if that value is less than 5, I'm going to get a response that this failed that rule, and I'm going to get this end user message that says, hey, you should be at least 5 millimeters, but you're currently 4, so you're currently failing this requirement. If I connect this into the CAD application and I get anything greater than 5 or 5 or greater, then I'm going to get this green condition. So that's how the rule processing engine is going to receive values, process the values, and display those values back, not necessarily within OROS, but within the CAD application. So let's dive into there. So we have a few rules here. I have one tooling rule that I'm going to do, even though it's part clearance, we're going to do a tooling one. This kind of shows a little bit of complexity. And we're going to make this all happen from the OROS connector. So again, regardless of which CAD application we're going to look at, it's going to be the same exact thing. So I just opened my connector, and we kind of took a look at how this functions. We have the 3 panels here. First one's telling me I'm connected to a set. So this model knew there's a set of knowledge packets it was connected to. And once I made that connection, it's showing me that there's 2 parameters that exist in that set of knowledge that don't exist in the model. So my very first thing before I do anything else, I'm going to add these into the model. So I'm going to create these unmatched parameters. Now at this step, maybe I need more than one. I could create as many instances of these as I need. So maybe I need to make 5 measurements of the motor, or maybe there's 4 holes, whatever it might be. I can create several instances of these particular parameters and then rule process against each instance. For this demonstration, we're going to use one. We're going to keep it simple and try to end on time. So at this point, I have my parameters in my model. So you can see my parameters here inside of the Oros NX connector. And if we look inside of NX, you can see those same parameters and their rule processing states inside of the part navigator. So we have data being synchronized across these 2 applications, same exact thing. But what I also want you to notice is we have these little icons here. And what that's telling me is that I have parameters that exist in the model that aren't connected to some sort of feature, whether it be a measurement, a dimension, a design feature like an extrude length, a part property, something such as that. My parameter isn't connected to anything. So I have a broken link. And you can see I have an incomplete status, meaning it's the parameter's in there, but it's not doing any work. So we're going to address all these things. So first thing we're going to do is we have a red condition sitting right there. So I want to show you how we can handle, or we can modify this. So if we take a look, whether we look inside the Oros connector here, or I look inside of NX, I can see that the end user message telling me, hey, this PC board, the panel clearance should be 25 millimeters, but it's currently 20 millimeters. So I'm failing this particular rule. So this one happens to be connected to a assembly constraint, right? So if I click on that assembly constraint, and let's go into edit. And I know the rule is 25. Maybe I didn't know that was the case when I developed my model. I update that to 25, and now that new value goes off, gets processed, and I can see I have a green condition. So I satisfied that rule. But I have 2 other rules here that aren't satisfied, right? I'm still unlinked. So if we look around, I have some fasteners on this particular assembly. And one of my rules has to do with tooling clearance. So let's kind of open up that connector again and take a look at this bolt hole center to wall nominal evaluation, right? So maybe I don't know what this is. I have knowledge being provisioned to me inside this application. As a CAD designer, I may not know the details about this, but within the application, I can click that knowledge packet and I can go right to the details. I can see this has to do with the minimum clearance for tooling to make sure that socket can fit, within that space provided to make a good connection onto the fastener. And it has something to do with the type of fastener we're using and the size of fastener, and based on that, there's a certain clearance I have to maintain in order to make these sockets work. So now I kind of understand what this rule is. Let's just close that for now. We're going to go back into our model. So I have let's get this out of the way so we don't have to see that. We're going to go in here. Let's turn off our fasteners because what I want to measure is this clearance from the center of that hole to the wall. And I have my parameter here, and it's not connected. There's no value. So a very simple way to make a connection is to just use a simple measure. Is this the only way to do it? Absolutely not. There's many different ways to make a connection to these parameters. For the sake of this particular demonstration, this is just one way. So we're going to edit this parameter and we're going to link it to a measure. So we're going to come into our part, kind of look in here. We're going to go to the center of this hole. Oh, I find my hole here. And we're going to go to the center line and we're going to measure to the wall. So it comes out with 10.5277 millimeters. I hit OK, and now that parameter, this bolt hole center to wall nominal, is going to be attached to the NX parameter P13, which is a distance measurement. And it's a persistent measurement that's going to stay in the application. So once I made that connection, that value is processed by the rule processing engine. The rule processing engine comes back and says, hey, it's too small. You need to increase the size of that pocket to get that, to let that socket fit in there. So depending on what design phase I'm in, I may have the ability to just change this. I can go into the assembly. I'm going to make the panel my work part. I'm going to come to my history. We're going to modify the sketch. I'm going to go to my pocket size, and we're going to increase this. Let's say 28 millimeters now is going to be my pocket. All right. So my pocket updates. I finished my sketch. Everything's modified. Let's go back to our assembly. We'll make that our work part. We zoom out, look around. Our holes are still there. And if we look at the part navigator, now our tooling requirement is now satisfied. So it's where it should be. So at this point, we have almost all of our parameters hooked up. But I kind of want to change course a little bit. We're not going to do the last one. With the time we have left, I want to show you what it means if new knowledge is introduced. So let's go back into our community and let's create a new knowledge packet really quickly. So we're going to create a new knowledge packet, and this is going to be for badge to panel clearance. And we're going to give it a quick value table. We're going to go to our value table editor. And again, we're going to tell it this is the badge to panel clearance. And give it a parameter name, badge to panel. And we're going to give it some units. Let's say this is in millimeters of length. The type is going to be a minimum, and our minimum value is going to be 20, right? So minimum value for the badge to the panel, 20 millimeters. We're going to set some criteria. What's the verification type? It's part-to-part clearance. What's the verification level? This is an assembly. And we're going to hit save. We're going to make this active because we can. It's a demo. And now we have our new knowledge created. Come back to our connector. And here you can see that knowledge packet I just created with that badge to panel parameter that I just created is now showing up and is telling me, not only in the panel, but in my model, hey, there's new knowledge I need to consume. At this point, I can create that particular parameter, and then I have all of the information inside of my model.
And Steve, we have one question. Nicole is asking, can you set a parameter to be surface to surface, or do you need a line point feature?
Can you set it to be surface to surface? So I think in the assembly constraints, if it is a surface to surface assembly constraint, I'm not sure how we would do that actually. I'd have to think about that one, Nicole. I'm not exactly sure. I've never tried it.
Well, good. So I guess you guys could connect separately on that. So that was a good question. Thank you. And Nicole also loves your trophy room. At least that's what it looks like.
Yeah.
Is it? It's a
Well, it's just
basement
the
area,
basement.
right?
Yeah, it's my man cave.
That's good. And just to let you all know, I did put the survey link for this session in. Yeah, I mean, officially we've run out of time, but we do have, about 4.5 minutes before the next one. So, but are you good, Steve? Anything else you want to kind of wrap it up with?
Oh, just kind of wrap
Yeah,
it up. I hope you
good.
can see how, using the connectors in the set of services, whether it be our off-the-shelf connectors or one you can build on your own. There's services available behind the scenes of Oros IQ that allow this knowledge connection to happen. And that's how we can provide knowledge as a service into the applications you use on a daily basis.
Perfect. And so Steve is actually going to run the next advanced
That's
breakout
right.
session, third and final, 2:45 Eastern. So in just about 4 minutes. So you'll just click on the schedule for that one. And this will be on document ingester and decision models. All right. So click the survey. We'll see you at the next session. Thanks, everyone.